Hello.
Hi,
Hi.
how's it going?
Good. How are you?
I'm doing pretty good. Just cooked dinner and it's settling down really good. So,
Good.
um, yeah. Um, hey, have you done this before?
Not on this platform. I have not.
Okay. So, kind of how this works. I don't know if you read up on it, saw examples, but hey, in the beginning we do typical interviews. In
Hmm.
my case, I've worked for Google and Microsoft, so I generally just give the 35-minute tech interview that we would there.
Okay.
Um, Following that, I give you the option to hear your feedback verbally. So
Okay.
I'll just tell you after if you want. But after that, you'll get feedback on the site about 10 minutes after, roughly. Um,
Okay.
I'll be filling that out after.
Okay.
Sound good?
Yes, it does.
You ready then?
Yes, I am.
Sweet. Quick question. Two questions.
Yeah.
Roughly, what level are you at in your career? And what programming language do you want to use?
I was going to use Java, and I would say I'm like a mid-level engineer. I've got
Okay,
about 6 or 7 years experience.
cool. All right. Um, I'm gonna give you this question then.
Okay.
Um, and by this, I know you don't see it yet, but
Yeah.
uh, so I don't know Java, so I might be asking questions and it may sound weird.
Okay.
It's just because I
Okay.
don't know Java.
Yeah. No problem. Yeah.
So I'm going to give you a list of points. It'll be XY coordinates.
Okay.
Let's just say it's a class. I'm going to write it like C++. Feel free to
Okay.
change it.
Sure.
Point. It's X and Y. Um, and then let's do distance in here, right?
Okay.
So that you're going to fill in. But also, I'm going to give you a list of points.
Okay.
It'll just be a two-dimensional plane in this case with a ton of points around it. I'm going to give you the vertex, so it's not going to be 0, 0 in most cases. Uh,
Okay.
and what I want you to do is find the nearest points around the vertex, and I'm going to give you an integer k, and that'll be your count. So let's say like 10.
Okay.
So in this case, I would want you to return the 10 closest points around the vertex.
Okay. All right. All right. I think that makes sense.
Great.
See, the what's the approximate number of points that could be expected to have to handle?
For now, let's just say it'll fit in memory.
Okay. Hmm.
What are your thoughts on this?
I'm just trying to think of if there's any other edge cases or any other bits of information that are important to collect before I start thinking about the solution too much.
Sure.
I mean, uh, I are the coordinates are going to be positive or could be negative?
They could be anything. It could be any double, even though I put int
It's yeah.
double. It could be
Okay.
anywhere in the planes.
Okay. All right.
Negative, positive, all that.
Sure. Okay. Um, and I can assume, I mean, there's going to be at least 10 points, and the vertex is not going to come in as null.
The vertex will not come in as null. I cannot guarantee anything with K.
Or okay. So you return, all points if the number of points is less than k.
Yes.
Okay. Okay. All right. Well, I'm gonna so I think I'm ready to at least start thinking about how I'd approach this. I might think of some other things to some other bits of information to collect later. But what my first thought is that it might be useful to order the points by their position on either axis, and then you could potentially do some like a binary search type of thing within each axis to find points that are likely to be the closest to the vertex.
Okay.
Were you gonna say something else?
No, I'm actually kind of curious if you continue down that route, how that's going to work. I've never seen someone attempt that, so.
Okay. I mean, I guess. Well, let's see. Yeah. I mean, that. I mean, the other. I mean, the obvious or the brute force solution is, you would take every. I mean, we have the vertex up front. We've got the list of points. You could iterate over the list, and yeah. No, this seems better. Calculate the distance between each point, and as we scan the list and the vertex, and then put them into a priority queue, and then at the end you would take the first k elements out of the priority queue, ordered by distance. And if if you reach if the priority queue is empty before you get to k, then you've got your, either way you have your answer. That would be I think that'd be an. Go ahead.
I was going to say, sounds like a reasonable approach.
Yeah. So I think that would be an n log n solution for n looking up n points and calculating their distance, and then a log n insertion into the priority queue.
So sounds like a good answer, but my question is, do you actually need to see every single, or do you need to store every single point in that queue?
No, you'd only need to maintain the 10 lowest you have. Yeah, so I guess that's a good point. Right, you wouldn't need to. You just need to say the k lowest. So you could do that with you could have a point array that is k elements long, and then you would maintain a pointer into the the naive solution would be, the lowest element goes into the 0th slot, and the kth element goes into the k-1 slot, right? But then every time that you find another lower one, you would have to shift all the elements. So what you could do instead is maintain a pointer to the head of the to which slot is currently the lowest we've ever found, and then if we find a lower one, insert to the the head -1th spot, mod k, and then update your head pointer. And then at the end.
So I get what you're going at, but is there a type of queue that can just do that for you? At least maintain where the max element is?
Right, that would be the priority queue, but wouldn't maintain. But finding the kth largest would be problem, or the.
Why not go the other way instead?
Oh yeah, right. Yeah, maintain a priority queue of the farthest element from the kth farthest element from the vertex we found so far, and then when we look up a new one, if the new one is closer to the vertex than the head of the priority queue, pop the head off the priority queue and insert the new one in.
Sounds better, actually.
Yeah.
So I don't know if you're satisfied with that, but it's like a reasonable thing to start with.
Yeah, I can get started with that. Okay. Yeah, I think I'll start with implementing distance. Should distance take I'm assuming should take the vertex like this? Or
just the point in general, yeah.
Yeah. Let's see, so that'll be I think it's I think that will work for the distance function.
Cool.
So then we'll have so I guess
So I don't actually know if list is a thing in Java.
it is.
You can use whatever you want.
Yeah, list is just an interface or an abstract type. It probably, array list and linked list would be the most common implementations.
Okay. I think it was array list I was thinking of, just an array of or points.
Yeah.
I haven't touched Java in like 5 or 6 years, so.
Yeah, no problem. I think, I did not mean to do that. That is a hotkey I'm not familiar with.
Don't forget about the vertex.
Right. Okay, so then we would create a priority queue, which is a Java class, and it's a concrete implementation.
Sure.
And then actually, so the second parameter to the priority queue to the priority queue constructor is a comparator, which takes two elements of whatever the templated type is, and then it's a function that returns an integer -1, 0, or 1 to compare the two elements. So so we can use that to so we want to make sure that it's properly distance function as to compare between points. The other way we could do this in Java is you could have this implement comparable and then implement a method on the class. I can do that if you want, but this way should also work fine.
Your call. I mean, I don't even know if that point class would work in my case. So. I assume it does. So if you want to add it there, that works.
Okay, I can do that. Yeah, actually, that. And I believe that you have to declare what it compares to if it's a subclass, but in this case, we don't have to worry about that too much. And then that would look like I don't remember if it's the if positive. Oh yeah, no, this won't work because of the vertex. But we could actually do this with down here in the closure. I believe that this Java actually would now allows us to do this. So yeah, like I was gonna say, I forget whether P1 greater than P2 implies -1 or the other way, but that'd be easy enough to figure out in the real world.
Yeah.
Okay, so now when we can put points into the priority queue, and the priority queue will store them in either min or max order, and it's easy enough to flip that if necessary. So then fairly, then we got to add the points to the priority queue. So if the priority queue isn't full yet, we can just just add the point without checking whether it's needs to go into the queue or not.
Sure.
So I guess to use the so I guess it's easier to matter. I think it's going to be they're going to be mutually exclusive. What we do in each case. So peak just takes a look at the top of the queue. Poll will take it off of the top. Okay. So I'm going to start by just peaking, and then if we have to remove it, we'll poll.
Sure. Looks all right so far.
Yeah. So I'm just thinking about whether there's anything else I need to do here. I mean, I know I need to construct the list at the end and return that. But just thinking about whether there's anything else I missed before I'm ready to do that.
There's something you can do to optimize it, but I don't know if you've looked at that yet.
Sorry, what was that?
So there is something you could do to optimize it at that point.
At the point of building the output list?
No, the point of the queue.
Okay. I think I'm just going to finish building the list, and then I will come back to that to think about some more. It might pop into my head as I'm doing this.
Yep.
All right. All right, is this, so the right side, I was just kind of looking around so what I'm thinking to do now is to walk through the code and make sure that this seems to work, and then also seeing if, I can think of any optimizations in the process of doing that. So I was just looking around the workspace here to see if there's any tools, like if I can't write on the right side, right? But there's this draw thing. Okay. I don't know if that's. Okay, so how to optimize this? Let's see. So a lot of the times when I get a problem like this, I mean, I do like to walk through, some just simple test cases. This problem is, I guess, a little bit trickier in that, some of doing the calculating which you can choose points that are very obviously closer and not closer. So I'm going to try to do here, but oh yeah, okay. So that actually does bring up is there any preferred ordering if there's a tie for the k and the kth and the k plus one closest
just the
points.
closest being
So
numerical distance.
Okay.
So
any
distance,
so if they're all okay. Okay, so the priority queue will take care of the ordering here, and if distance is correct and the comparator function is correct. But so we go in, we look at the first point. The k-los, the size of the queue is less than k, so we'll just add. We just add 1, 1. We do that for the first three, so we'll have -1, negative. I mean, this isn't going to be very interesting because I put them all at the front. I can move this guy. Okay, so so we get that, and then we come in and we look at, so now we're looking at 1, -1. And the k-low so far size is 3, it's equal to k. I guess really we don't need the greater than, but it should be that, I guess.
Mm-hmm.
And okay, yeah, and the priority queue is going to be ordered. So it does end up, it should be like this. So we'll, so case is now going to be Q2. Compare their distance. The distance for 2, 2 is going to be greater than the distance for 1, -1. So we take it out of the queue, and then we add 1, -1, and then do the same thing. Then we come in with -2, -2. We peak 1, 1, 1, but the -2, -2 is greater distance than 1, 1, so we should just continue, and then we build the list. So at least for this relatively simple example, I think it works.
Can we try it out?
Oh yeah. Do you? Yeah. Do you have a run it, or do you have like a input you want to give it, or?
Whatever you just used, yeah,
Sure.
that would work.
Okay. Sure. I shouldn't get too clever.
Yeah. Sweet.
Right. Let's run it. Really. Oh, yeah. Okay, so it's complaining because distance returns doubles and the comparator function return in it. But that's,
Well, just cast it.
I mean, I could do like, I could just cast it to an int. Yeah, that should work.
Well, I'd cast the whole thing, not the first.
yeah. I guess yeah. So I could be that there's a rounding error there if it's,
Yeah.
well, no, that shouldn't, in this case it shouldn't be, but
I say
I'm just gonna.
we should stop with this one. I have
Good.
I have something to extend on
Okay.
this. Um,
Okay.
I want to change this a little bit. I don't know if
Okay.
Java has a data stream, like C++ or Python. Uh, but a data stream, if you don't know what it is basically a continuous input of points. It works very much the
Right.
same with like a for each or 4.in. Yeah. Um, so it
Mhm.
wouldn't change much in terms of
Mhm.
how it's read. So I
Right.
the trick to it is the data stream will never end. It will have
Right.
an infinite number of points. How do we adjust to
Mhm.
return the k closest?
Um. So.
So it always start at the beginning, but
Right.
yeah.
Right. So. So you want this to like return synchronously, and like, so I'm imagining like this stream is this is like maybe it's like a sensor value, right? And that, like, we want to get the k closest, or yeah, the k closest so far, but then the
No,
sensor.
no, because what it'll do is it'll give you the very beginning of the list, and then just continuously keep coming in. What I want is the k nearest for the entire list. Um, we know that it will never end. So
Right.
how do we say it ends?
Sorry, what, how do we?
If it never ends, how do we end it and say these are the k closest?
um
At some point, you should stop, right?
right. Yeah. Is there a um I mean, do we know anything? Are the points ordered at all?
No.
Is there any other? No. Um, and we're not looking for the k closest within some distance or within some precision. It's
Well,
just
so
the absolute closest.
let's go down the line of precision, and I guess within a number of points as well. Can we create some sort of like precision slash threshold that we could call it quits after we reach it?
Um, I mean, if you had k points that were equal to the vertex, then you would
Right.
obviously
That would be
be able
obvious.
to return. Yeah. I mean, we're doing a double comparison here. Double is the double representation is imprecise, right? So you could, I mean, if you had, I think that if you're comparing double equality, that the language would probably, or the runtime would take care of being within, the like rounding error um, through double math. That, like, if one point is close enough to the vertex so that the distance is indistinguishable by the double data type, it would evaluate to equals. Um, I can't. I'm not really certain what. I mean, if the stream
So
is infinite.
let's go back to your precision. What was in your head when you said that? Um, what were your thought process on that?
Um, I mean, if we knew that we wanted to get k points that were within a certain arbitrary distance of the vertex, that would be, that would be an easy stopping point to find,
Right.
right?
So
when you add the k,
let's look at that then, right? We want an arbitrary threshold error ratio, right?
Okay.
But you also don't want to, let's say the first six elements are under that. You just don't want to quit, right? So should you factor in some sort of number of points seen as well?
Right. Yeah, I know that there's like some sort of like uh, this sort of problem. I have heard about some sort of like a theorem or an algorithm that, yeah, you're supposed to collect a certain number up front to kind of get a sense of what your data stream looks like, and then and like what you can expect the kth best to be, and then after you've determined you've collected enough data, you set your threshold yourself, and then after that, the first k elements that satisfy the threshold, you would return. I don't know the math behind that for like what the optimal ratio is. I know that there's some sort of
what if you created like a sliding window with the two requirements having to be met, both the threshold and the number of points. And if you don't meet it, you increase both, right? Would something like that work?
So you would have, so you're saying we would have so we'd have some sort of, you'd have a window, like a window of points, like number of points. This is a long name, but I would shorten it. But and then we'd have the threshold, like termination threshold. And then if within, so let's say this is, like 1,000 points or something, and then this is, like this is 2, right? If we don't have k points within 2 of the vertex in the last 1,000 points we've seen, we would then we increase the window somehow. That's what you're suggesting?
Yeah, the window and like the threshold, right?
Yes, that would make sense. I guess I'm not
appropriate way to do it.
Could certainly. One thing I was thinking, like I guess, like this is kind of seeming like an experiment to me, and like when I'm dealing with an experiment, I try to keep one, try to only change one variable. So what I was thinking in my head was like, would it make sense to potentially on alternate iterations, like we last increase the threshold, so then we increase the window, and then if we can't satisfy it in the window, then we increase the threshold, and then that way, it's possible that just increasing one of the conditions would have satisfied your. But I don't know if that's a worthwhile complication to add.
Well, the reason I would see it that way is because let's imagine we're working with space, and you're not 2 miles away. The next item is like 2,000 light years away.
Sure.
Something you have to worry about. Let's stop here.
Okay.
Did you want to hear kind of your verbal feedback before I write it out, or do you want to write it out? And what are your thoughts on
that? I'm fine with whatever you want to. I would hear my feedback if you are ready to give it.
Sure. So let's start from the beginning. I'm glad you clarified most of the edge cases. You missed a couple, like what if k was negative?
Oh yeah.
So I'm happy you did that, but you didn't actually do it. Um, like all the conditions are can still be done. I would have liked to see it being implemented. Uh,
Okay.
you also might have taken a little bit longer than I would have preferred because you didn't really
Okay.
get a working solution. Um, you got to where it could compile and run, but your code wasn't right. Um, I mentioned that there's an optimization with the queue.
Mm-hmm.
I'm not going to hit on that just because it's a little bit better. But if you're curious, think about how often you're recomputing the distance every time you hit by or insert or check and stuff like that.
Right. Yeah, that makes sense.
So I check four things when I evaluate someone.
Okay.
First one is your technical ability. Do you write code? Do you follow a style guide? Do you check edge cases? Do you throw exceptions when needed? And so on. And surprisingly, for the first time, I've on this platform, I interview elsewhere as well. Um, Someone has actually had non-vague variable names. I don't know why it's so hard to write normal names that make sense. Most people are just like I and something else, like two-letter names. Um,
Right.
so nice on that. It's also great to see kind of classes and stuff worked out. So I have a question Java-wise. Every other person I've
Yeah.
talked to with Java started the main with creating an instance of solution, but you didn't.
Yeah.
So clearly it's not required from the looks of things.
Right.
I just don't know why they would think to do that.
Do you want an answer or?
Yeah, sure.
uh,
If it's quick.
I mean, the big thing is, I mean, in Java, typically, static methods like this are typically not encouraged by most Java style guides.
Okay.
But that would be the closest thing to just like a pure function that Java has for the most part. And for the sake of a problem like this, it wouldn't exactly to make a static method for doing this wouldn't really if you're building a big Java system would probably be discouraged. But
Sure.
these sort of problems are pretty self-contained, and that's just the quickest, easiest, and clearest way to solve it, in my opinion.
Makes sense. Anyway, back to my feedback. The queue, it took you a little bit. I had to give you a couple hints, but only a couple really. So you're able to get it when I asked about if you can, let's say, use the max up front instead of the min.
Right.
It took you a couple of times of me asking it in different ways for you to finally click what I was asking. But you did get it eventually. So overall, technical ability was pretty good. Not perfect, not bad either. So um, I did like that you were considering edge cases, but we didn't really have the chance beyond one thing to test.
Right.
Your code was a little bit slow. If at a mid-level, senior level engineer, I kind of expect people to go a little bit faster to be able to get a
Okay.
good starting point to where it's running probably half the time, and then start optimizing and using test cases and stuff like that. So I'd work on speeding things up a little bit. Good that
So
you're. Oh, go ahead.
so you would prefer running test cases through the platform uh, instead of working through them by hand. Is that one of your?
Yeah, because I want to see it working.
Okay.
If we have a
Sure.
platform like this, if it's a whiteboard, obviously that's not the case, but I'd like to still see code that worked.
Right.
Uh, yeah, so even when it's on the whiteboard, what I would do is just say, hey, write out at least one test case in full code, and then tell me the rest. Okay,
Okay.
so part two I look at is your knowledge of algorithms and data structures. I didn't really see any bad things when you knew. The only thing that questioned me was what the binary search thing was in the beginning, and
Oh, yeah.
I generally have an idea of what you're going for because there's an algorithm called the KD tree, and it allows you to not look at every element and be able to determine with an error threshold what the top K is. So it might have been very similar to that. We just didn't investigate hard.
Right.
So yeah, generally speaking, I would have loved for you to catch the max heap faster, but overall algorithm data structure was fine. And you could code. And then I get into communications. I have no problems with that. And then we get into the big part for me, and that is your problem solving. So technical ability is kind of a small part compared to your problem solving. We need to know you can solve problems more than you can code, even though we still need you to code. I got a little bit of that with the main algorithm itself, but the part I mostly look at when it comes to problem solving is one of four things, and you got the one that was, hey, if there's an infinite number of points, how do you change this? How do you look at a different approach and take something that you clearly probably do not know how to solve? Most people don't, because it's a whole different concept. And how do you find a way, even with subtle hints, to come up with a reasonable solution? And for that, I'm up in the air because it seemed like I held your hand in a direction, but once you figured out what I was getting at, it became a little bit more clear. And you started working on, at least idea-wise, on what it was I was looking for, or what a possible option could be, I mean.
Right.
So your problem solving is, from what I could tell, decent, but not, again, this is an interview thing. It was probably great, but from what I could tell in 35 minutes, needs a little bit of work.
Okay.
Again, that's not on your ability to actually solve problems. It's just what you can do in 35 minutes.
Right.
So I'd work on maybe trying to work on stuff that you don't know, and see if you can quickly come up with possible solutions.
Okay.
The key here is that you're not going to be writing code for it.
Okay.
So it's more of if you go into a design meeting, or you're running a system a design doc, what are your initial thoughts? And can you come up with a solution, basically asking someone kind of their opinion or thoughts and so on, like that.
Okay.
That make sense?
Yeah, it does.
Do you have any questions?
I guess for the problem solving part, like I take it that you're talking about like the stream, and then we had to kind of change the conceptualization of the problem, right? Like the way the problem is asked, you can't just choose a starting point or a terminating point, right? You need to come up with some reasonable other criteria. I guess what I've been kind of trained, or like thought that maybe just from doing practice with like online things where you don't get to talk to a human and like, you know, have like engage with them, that like, you know, the problem is what is stated, and like there might be hidden information in the you know, in the sense of you know, edge cases aren't mentioned, or like there might be a property in the data that's useful that you have to ask about to be able to take advantage of. But then kind of, well, I guess, yeah. I guess in this case, like the question is like you have an infinite stream when you want the k smallest or the k closest in the stream. It's like, well, that's as stated, like that's like not possible,
it's a tough
right?
question. It's not possible with a perfect k, unless like sorted or something. But as far as is it possible with the threshold? Yeah, very
right.
possible.
Yeah.
So some people do it differently. I throw in a question that you're not going to solve in the remaining time, if at all. But I
Right.
want to see how you tackle something that you don't know and see if you could take subtle hints to bring that aha moment. This could work. What if I did this type of place in the interview?
Right.
And if you go there, you did really, really, really well. And I asked the same question to everyone, except for I changed one of the really hard ones to one of four things. Most people I don't expect to actually solve it, but I do want to see some progression depending on what level you're at. And as a mid-level, senior level engineer, I do want to see some effort with it and see some direction. Keep in mind, not everyone does this. Not everyone will give you something like that. They'll evaluate it in their own way, or they just won't evaluate it. I'm just one example of what could happen. So,
sure.
If that makes sense, I don't know if that answered your question fully.
I mean, it helps, and I think it is kind of just a question. Like, I guess my thought is like, when you'd asked me that, and I'd said, well, as stated, that's not possible. But if we, have some additional condition, then then the problem is possible. Like, would that have been a good answer? Or
yes. Yeah, that would have been great, and I would have loved for you to go into what those conditions were. Some ideas on what conditions may be.
Okay.
Obviously, you wouldn't know right away, but kind of, hey, what if we started looking at this?
Okay.
That's why I gave it to you. I gave you an impossible question that, with some sort of modification with conditions, is possible.
Right.
That's kind of the problem-solving part. Is how does he take something impossible and make it possible?
Okay.
So, again, not everyone asks like that. It's just kind of my thing when it comes to problem solving. That's how I evaluate people. Because you can evaluate someone's basic problem solving with the first part. Hey, how does he do?
Right.
Yeah. I just don't get the full range of what you can do with that.
Sure.
So,
that makes sense.
I got time for like one last question.
I don't know.
Yeah. Well, if not, I could just jump off, give you your feedback. So as far as like a result, if you're on a phone screen, I would have definitely advanced you. If this was for a hire or no hire decision, I would swing to a very weak no hire, which means I'm on the edge of saying hire or no hire. And the reason being is because at your level, I kind of expected you to go a little bit faster with this. And then spend more time on a bigger problem solving part, if anything.
Sure.
If you were like junior, I would have passed you. So it's just, as you go up in the levels, the more criteria I look for. So hopefully that's a good starting point. Yeah, please feel free to come by and interview with other people as well. I'd probably ask people like, can you do system design or something like that, and get that perspective as well. So,
sure.
Just some food for thought.
Yeah. No, it makes sense. I appreciate it.
Yeah, no problem. I had a blast. Hopefully you did as well. So,
Yeah, this was very helpful. It was you're a good interviewer, and I
Okay.
do appreciate the feedback. It's much more, it's more informative than basically any other way of practicing. So,
Yeah,
thank you.
great. Well, have a good one.
Thank you. You
I'll
too.
be submitting your feedback here very shortly. And
Okay.
they'll have a survey for what you think about me as well. So feel free to be honest with that.
Okay.
Take care.
All right. Cool. Yeah, you too. Have a good night.
You too. Bye.